Hello viewers, welcome to my channel Online Biology Tutorials. In today's live we will be reading chapter 3 Metals and Non-Metals taken from grade 10 Science NCERT that is followed in CBSE board. I have recorded the audio of the first two chapters. In case you are interested, you can visit the playlist. There is one more playlist of grade 10 audiobook, but that is with the background music. I hope the screen is clear to everybody. Let's get started. So, Chapter 3 Metals and Non-Metals, Class 10 Science NCERT. In Class 9, you have learned about various elements. You have seen that elements can be classified as metals or non-metals on the basis of their properties. Think of some uses of metals and non-metals in your daily life. What properties did you think of while categorizing elements as metals or non-metals? How are these properties related to the uses of these elements? Let us look at some of these properties in detail. 3.1 Physical Properties. 3.1.1 Metals. The easiest way to start grouping substances is by comparing their physical properties. Let us study this with the help of the following activities. For performing activities 3.1 to 3.6, collect the samples of following metals: iron, copper, aluminium, magnesium, sodium, lead, zinc, and other metal that is easily available. Activity 3.1. Take samples of iron, copper, aluminium, and magnesium. Note the appearance of each sample. Clean the surface of each sample by rubbing them with sandpaper and note their appearance again. Metals in their pure state have a shiny surface. This property is called metallic luster. Activity 3.2. Take small pieces of iron, copper, aluminium, and magnesium. Try to cut these metals with a sharp knife and note your observations. Hold a piece of sodium metal with a pair of tongs. Caution: always handle sodium metal with care. Dry it by pressing between the folds of a filter paper. Put it on a watch glass and try to cut it with a knife. What do you observe? Next page. You will find that metals are generally hard. The hardness varies from metal to metal. Activity 3.3. Take pieces of iron, zinc, lead, and copper. Place any one metal on the block of iron and strike it 4 or 5 times with a hammer. What do you observe? Repeat with other metals. Record the change in the shape of these metals. You will find that some metals can be beaten into thin sheets. This property is called malleability. Did you know that gold and silver are the most malleable metals? Activity 3.4. List the metals whose wires you have been seen in daily life. The ability of metals to be drawn into the wires is called ductility. Gold is the most ductile metal. You will be surprised to note that a wire of about 2 kilometer length can be drawn from 1 gram of gold. It is because of its malleability and ductility that metals can be given different shapes according to our needs. Can you name some metals that are used for making cooking vessels? Do you know why these metals are used for making vessels? Let us do the following activity to find out the answer. Activity 3.5. Take an aluminium or copper wire. Clamp this wire on a stand as shown in figure 3.1, this one. Fix a pin to the free end of the wire using wax. Heat the wire with a spirit lamp, candle, or a burner near the place where it is clamped. What do you observe after some time? Note your observations. Does the metal wire melt? The above activity shows that metals are good conductors of heat and have high melting points. The best conductors of heat are silver and copper. Lead and mercury are comparatively poor conductors of heat. Do metals also conduct electricity? Let us find out. Next page. Activity 3.6. Set up an electric circuit as shown in figure 3.2. This one. Place the metal to be tested in the circuit between terminals A and B as shown. Does the bulb glow? What does this indicate? You must have seen that the wires that carry current in your homes have a coating of polyvinyl chloride or PVC or a rubber like material. Why are electric wires coated with such substances? What happens when metals strike a hard surface? Do they produce a sound? The metals that produce a sound on striking a hard surface are said to be sonorous. Can you now say why school bells are made of metals? 3.1.2 Nonmetals. In the previous class, you have learned that there are very few non-metal as compared to the metals. Hi Nitesh, welcome to today's live. Some of the examples of non-metals are carbon, sulfur, iodine, oxygen, hydrogen, etc. The non-metals are either solids or gases except bromine, which is a liquid. Do non-metals also have physical properties similar to that of the metals? Let us find out. Activity 3.7. Collect samples of carbon, coal or graphite, sulfur, and iodine. Carry out the activities 3.1 to 3.4 and 3.6 with these nonmetals and record your observations. Compile your observations regarding metals and nonmetals in table 3.1. So in table 3.1, you are asked to write element, symbol, type of surface, hardness, malleability, ductility, conducts electricity, and also about sonority. On the basis of the observations recorded in Table 3.1, discuss the general physical properties of metals and nonmetals in the class. You must have concluded that we cannot group elements according to their physical properties alone, as there are many exceptions. For example, 1. All metals except mercury exist as solids at room temperature. In activity 3.5, you have observed that metals have high melting points, but gallium and cesium have very low melting points. These two metals will melt if you keep them on your palm. Iodine is a non-metal, but it is lustrous. Carbon is a non-metal but can exist in different forms. Each form is called an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting point and boiling point. Graphite, another allotrope of carbon, is a conductor of electricity. Alkali metals like lithium, sodium, potassium are also soft, that they can be cut with a knife. They have low densities and low melting points. Elements can be more clearly classified as metals and nonmetals on the basis of their chemical properties. Activity 3.8. Take a magnesium ribbon and some sulfur powder. Burn the magnesium ribbon, collect the ashes formed, and dissolve them in water. Test the resultant solution with both red and blue litmus paper. Is the product formed on burning magnesium acidic or basidic? Now burn sulfur powder. Place a test tube over the burning sulfur to collect the fumes produced. Add some water to the above test tube and shake. Test the solution with blue and red litmus paper. Is the product formed on burning sulfur acidic or basic? Can you write equations for these reactions? Most non-metals produce acidic oxides when dissolved in water. On the other hand, most metals give rise to basic oxides. You will be learning more about these metal oxides in the next section. In-text questions. 1. Give an example of a metal which 1. Is a liquid at room temperature, can be easily cut with a knife. Third is a best conductor of heat. Fourth is a poor conductor of heat. Question number 2. Explain the meanings of malleable and ductile. 3.2. Chemical properties of metals. We will learn about the chemical properties of metals in the following sections 3.2.1 to 3.2.4. For this, collect the samples of following metals: aluminium, copper, iron, lead, magnesium, zinc, and sodium. Next page, please. 3.2.1. What happens when metals are burnt in air? You have seen in activity 3.8 that magnesium burns in air with a dazzling white flame. Do all metals react in the same manner? Let us check by performing the following activity. Activity 3.9. Caution. The following activity needs the teacher's assistance. It would be better if students wear eye protection. Hold any of the samples taken up with a pair of tongs and try burning over a flame. Repeat with the other metal samples. Collect the product if formed. Let the products and the metal surface cool down. Which metal burns easily? What flame color did you observe when the metal burnt? How does the metal surface appear after burning? Arrange the metals in the decreasing order of their reactivity towards oxygen. Are the products soluble in water? Almost all metals combine with oxygen to form metal oxides. Metal plus oxygen will give metal oxide. For example, when copper is heated in air, it combines with oxygen to form copper oxide. Oxidation state is 2 here, a black oxide. 2Cu plus O2 will give you 2CuO. Cu is copper, CuO is copper chloride, oxidation state is 2. Similarly, aluminium forms aluminium oxide. 4Al plus 3O2 will give you Al2O3. To balance the equation, we need to put 2 here. Al is aluminium, Al2O3 is aluminium oxide. Recall from chapter 2 how copper oxide reacts with hydrochloric acid. We have learned that metal oxides are basic in nature, but some metal oxides, such as aluminium oxide, zinc oxide, show both acidic as well as basic behavior. Such metal oxides, which react with both acids as well as bases to produce salts and water, are known as amphoteric oxides. Aluminium oxide reacts in the following manner with acids and bases. Al2O3 plus 6HCl will give you 2AlCl3 plus 3H2O. Al2O3 plus 2NaOH will give you 2NaAlO2 plus H2O, that is sodium aluminate. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis as follows. Na2O in the solid form will react with water in the liquid form to produce 2NaOH in the aqueous form. K2O in the solid form plus H2O in the liquid form will form 2KOH in the aqueous form. Let's move to the next page. We have observed in activity 3.9 that all metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. Hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. At ordinary temperature, the surface of the metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of oxide. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron fillings burn vigorously when sprinkled in the flame of the burner. Copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Silver and gold do not react with oxygen even at high temperature. Do you know anodizing is a process of forming a thick oxide layer of aluminium? Aluminium develops a thin oxide layer when exposed to air. This aluminium oxide coat makes it resistant to further corrosion. The resistance can be improved further by making the oxide layer thicker. During anodizing, Jayom Yadav, welcome to Online Biology Tutorials Live. I am ma'am, not sir. The resistance can be improved further by making the oxide layer thicker. During anodizing, a clear aluminum article is made the anode and is electrolyzed with dilute sulfuric acid. The oxygen gas evolved at the anode reacts with aluminum to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminum articles an attractive finish. After performing activity 3.9, you must have observed that sodium is the most reactive of the subsamples of metals taken here. The reaction of magnesium is less vigorous, implying that it is not as reactive as sodium. But burning in oxygen does not help us to decide about the reactivity of zinc, iron, copper, or lead. Let us try some more reactions to arrive at a conclusion about the order of reactivity of these metals. Jayom Yadav. Shortly, I will be starting live in the night time, maybe around 9 p.m. or 10 p.m. I will be starting for class 10th on Tuesday, right? So Tuesday is the day that I have decided I will be going live for the explanations of science chapter. I will leave a post on my channel. You can subscribe if it is helpful to you so that you can get the notification. 3.2.2 What happens when metals react with water? Activity 3.10 Caution, this activity needs the teacher's assistance. Collect the samples of the same metals as in activity 3.9. Miss Tidbit has just joined. Hi and welcome to my channel. Collect the samples of the same metals as in activity 3.9. Put small pieces of the samples separately in beakers half filled with cold water. Which metals reacted with cold water? Arrange them in the increasing order of their reactivity with cold water. Did any metal produce fire on water? Does any metal start floating after some time? Put the metals that did not react with cold water in beakers half filled with hot water. For the metals that did not react with hot water, arrange the apparatus as shown in figure 3.3 and observe their reaction with steam. Which metals did not react even with steam? Arrange the metals in the decreasing order of reactivity with water. Next page. Metals react with water and produce a metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve in it to further form metal hydroxide. But all metals do not react with water. Metal plus water will give you metal oxide plus hydrogen. Metal oxide plus water will give you metal hydroxide. Metals like potassium and sodium react violently with cold water. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. So 2K in the solid form will react with H2O in the liquid form to form 2KOH. Here water molecules are 2. 2KOH aqueous plus H2 gas plus heat energy. 2Na plus H2O, Na in solid form, H2O in liquid. Two molecules of water will give you 2NaOH in aqueous form plus H2 in gaseous form plus heat energy. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Calcium in solid form and H2O in liquid form, two molecules of of water, will combine to form calcium hydroxide CaOH2 in aqueous form along with the hydrogen in the gaseous form. Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Magnesium does not react with cold water, it reacts with the hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminium, iron, and zinc do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. 2Al means aluminium. Two molecules in the solid form will react with H2O water. Three molecules in the gaseous form will form Al2O3 solid, means aluminium oxide, plus three molecules of hydrogen gas. That is why it is written G. 3Fe means three molecules of iron in the solid form will react with water H2O in the gaseous form, will form Fe2O4, which is iron oxide in the solid form, plus hydrogen gas will be evolved, four molecules of it. Metals such as lead, copper, silver, and gold do not react with water at all. 3.2.3 What happens when metals react with acids? You have already learned that metals react with acids to give salt and hydrogen gas. Next page, please. Metal plus dilute acid will give you salt and hydrogen. But do all metals react in the same manner? Let us find out. Activity 3.11 Collect all the metal samples except sodium and potassium again. If the samples are tarnished, rub them clean with sandpaper. Caution, do not take sodium and potassium as they react vigorously even with cold water. Put the samples separately in test tubes containing dilute hydrochloric acid. Suspend thermometers in the test tube so that their bulbs are dipped in the acid. Observe the rate of formation of bubbles carefully. Which metals react vigorously with dilute hydrochloric acid? With which metal did you record the highest temperature? Arrange the metals in the decreasing order of reactivity with dilute acids. Write equations for the reactions of magnesium and aluminum, zinc, and iron with dilute hydrochloric acid. Hydrogen gas is not evolved when the metal reacts with nitric acid. It is because HNO3 is a strong oxidizing agent. It oxidizes the H2 produced to water and itself gets reduced to any of the nitrogen oxides, which could be N2O, NO, or NO2. But magnesium, which is Mg, and manganese, which is Mn, react with very dilute HNO3 to evolve H2 gas. You must have observed in activity 3.11 that the rate of formation of bubbles was the fastest in the case of magnesium. The reaction was almost the most exothermic in this case. The reactivity decreases in the order magnesium, then aluminum, then zinc, then iron. In the case of copper, no bubbles were seen and the temperature also remained unchanged. This shows that copper does not react with dilute HCl. Do you know aqua regia, Latin word for royal water, is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio 3 is to 1. It can dissolve gold even though neither of these acids can do so alone. Aqua regia is a highly corrosive fuming liquid. It is one of the few reagents that is able to dissolve gold and platinum. 3.2.4. How do metals react with solutions of other metal salts? Activity 3.12. Take a clean wire of copper and an iron nail. Put the copper wire in a solution of iron sulfate and the iron nail in the solution of the copper sulfate taken in test tubes as shown to you in figure 3.4. Record your observations after 2 minutes. Next page. In which test tube do you find that a reaction has occurred? On what basis can you say that a reaction has actually taken place? Can you correlate your observations for the activities 3.9, 3.10, and 3.11? Write a balanced chemical equation for the reaction that has taken place. Name the type of reaction. Reactive metals can displace less reactive metals for their compounds in the solution or molten form. We have seen the previous sections that all metals are not equally reactive. We check the reactivity of various metals with oxygen, water, and acids, but all metals do not react with these reagents. So we were not able to put all the metal samples we had collected in decreasing order of their reactivity. Displacement reactions studied in chapter 1 give better evidence about the reactivity of metals. It is simple and easy. If metal A displaces metal B for its solution, it is more reactive than B. Metal A plus salt solution of B, salt solution of A will be formed in metal B. Which metal, copper or iron, is more reactive according to your observations in activity 3.12? So in figure 3.4, they have shown you reaction of metals with salt solutions. 3.2.5, the reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activities. After performing displacement experiments, activities 1.9 and 3.12, the following series, table 3.2, known as the reactivity or the activity series, has been developed. So table 3.2 is the activity series that is telling you the relative reactivities of metals. So they are arranged from most reactive to reactivity decreases and then to the least reactive. The series includes the elements potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. The symbols of all these are to be learned too because this is how they will be written in the chemical reactions. Next page. In text questions. Question number 1. Why is sodium kept immersed in the kerosene oil? 2. Write equations for the reactions of 1. Iron with steam, and then second one, calcium and potassium with water. Question number 3. Samples of 4 metals A, B, C, D were taken and added to the following solution one by one. The results obtained have been tabulated as follows. So metal A has not given any reaction to iron sulfate but given a displacement reaction to copper sulfate, no reaction to zinc sulfate or to silver nitrate. B has given displacement reaction to iron sulfate, no reaction to copper sulfate, no reaction to zinc sulfate, and silver nitrate. Metal C has not given any reaction to iron sulfate and no reaction to copper sulfate and zinc sulfate, but displacement reaction to silver nitrate. D. No reaction to iron sulfate, copper sulfate, zinc sulfate, or to silver nitrate. Use the table above to answer the following questions about metals A, B, C, and D. 1. Which is the most reactive metal? 2. What would you observe if B is added to a solution of copper sulfate? This is the oxidation state 2 here. Then 3. Arrange the metals A, B, C, D in the order of decreasing reactivity. 4. Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction when iron reacts with dilute H2SO4. 5. What would you observe when the zinc is added to a solution of iron 2 sulfate? Write the chemical reaction that takes place. Next one, 3.3. How do metals and nonmetals react? In the above activities, you saw the reactions of metals with a number of reagents. Why do metals react in this manner? Let us recall what we learned about the electronic configuration of elements in class 9. We learned that noble gases which have completely filled valence shell show little chemical activity. We therefore explain the reactivity of elements as a tendency to attain a completely filled valence shell. Let us have a look at the electronic configuration of the noble gases and some metals and nonmetals. We can see from table 3.3 that a sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So there is a net positive charge giving us a sodium cation Na+. On the other hand, chlorine has 7 electrons in its outermost shell. Next page. Table 3.3 is showing you the electronic configuration of some elements. So noble gases are helium, neon, argon, and the atomic number of helium is 2, neon is 10, argon is 18. So the number of electrons in the helium K shell will be 2. In the case of neon, in the K shell it will be 2, in the L shell it is 8, in the argon it is atomic number 18, so it is going to be K 2 electrons, L 8 electrons, and M 8 electrons. So the metals that are being shown to you, sodium, magnesium, aluminium, potassium, calcium, the atomic numbers are given here. You should practice all these by writing on a piece of paper or on your notebook. Non-metals that are given to you are nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. These are the metals when they are neutral. So you should practice for their electronic configuration when they are in the cationic or anionic form as well. And it requires one or more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L, and M shells. This gives us a chloride anion or chloride minus. So both these elements can have a give and take relation between them as follows. So here Na is having one electron, valence electron. So it is easy to lose one than to grab seven. Similarly, for chlorine having the electronic configuration as 287, so it is easy for chlorine to grab one. So it will take one from the sodium. That is why, because it has given, that is why it is Na plus. And because chlorine has taken, that is why it is minus. So here the plus charge element is cation. Chlorine is an anion. So similarly, this has been shown to you. So whenever there is a transfer of electrons, we always say that ionic bond is formed. You can join my live in the upcoming week. A notification will definitely reach you through the post of my channel. Stay updated to receive those updates so that you can join the live. Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride or NaCl. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Let us see the formation of one more ionic compound, magnesium chloride, in figure 3.6. Next page, please. So similarly here it has been shown to you magnesium has got two valence electrons. So for magnesium it is easy to lose 2 than to grab 6 because to complete its octet it requires 6 more. So chloride here it is having 7 valence electrons. So what is going to happen? One electron will be taken from magnesium, right? So magnesium, as it is having two valence electrons, it has capacity to give to two chlorine atoms. That is why the formula is like MgCl, because we do it with the MgCl too because of the crisscross method, right? In some video further, we can understand the crisscross method as well, which is used to write the formula of a compound or a molecule. The compounds formed in this manner by the transfer of electrons from a metal to a non-metal are called ionic compounds or electrovalent compounds. Can you name the cation and anion present? So I have already told you the one with the plus charge is cation, the one with the negative charge is anion. 3.3.1 Properties of ionic compounds. To learn about the properties of ionic compounds, let us perform the following activity. Activity 3.13. Take samples of sodium chloride, potassium iodide, barium chloride, or any other salt from the science laboratory. What is the physical state of these salts? Take a small amount of a sample on a metal spatula and heat directly on the flame, as shown in figure 3.7. Repeat with other samples. What did you observe? Did the samples impart any color to the flame? Do these compounds melt? Try to dissolve the samples in water. Petrol and kerosene, are they soluble? Make a circuit as shown in figure 3.8, this one, and insert the electrodes into a solution of one salt. What did you observe? Tells the other salt samples too in this manner. What is your inference about the nature of these compounds? Table 3.4, melting and boiling point of some ionic compounds has been given to you. So please note melting point is in Kelvin, same as boiling point, and Kelvin is the SI unit of temperature. So the ionic compounds that are given to you are NaCl, sodium chloride, lithium chloride, calcium oxide, magnesium chloride, and so is their chemical formula. Lithium chloride is LiCl, calcium chloride is CaCl2, calcium oxide is CaO, magnesium chloride is MgCl2. So here you can find it out that the melting point among all these given ionic compound is maximum for CaO, and here the boiling point is also the maximum for CaO. So this way you should learn all the values can be asked to you in the board examination. Next page. You have also observed the following general properties for ionic compounds. 1. Physical nature. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and the negative ions. These compounds are generally brittle and break into pieces when pressure is applied. 2. Melting and boiling points. Ionic compounds have high melting and boiling points. See table 3.4. This is because a considerable amount of energy is required to break the strong inter-ionic attraction. 3. Solubility. Electrovalent compounds are generally soluble in water and insoluble in the solvents like kerosene, petrol, etc. Fourth, conduction of electricity. The conduction of electricity through a solution involves a movement of charged particles. A solution of an ionic compound in water contains ions which move to the opposite electrodes when electricity is passed through the solution. Ionic compounds in the solid state do not conduct electricity because of the movement of ions in the solid is not possible due to their rigid structure, but ionic compounds conduct electricity in the molten state. This is possible in the molten state since the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. Thus, the ions move freely and conduct electricity. In text questions 1. Write the electron dot structures for sodium, oxygen, and magnesium. 2. Show the formation of Na2O and MgO by the transfer of electrons. 3. What are the ions present in these compounds? 2. Why do ionic compounds have high melting points? 3.4. Occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the earth crust are known as minerals. At some places, minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores. 3.4.1 Extraction of metals. So, 3.4.1 Extraction of metals. Just wait a second. 3.4.1 Extraction of metals. You have learned about the reactivity series of metals. Having this knowledge, you can easily understand how a metal is extracted from its ore. Some metals are found in the Earth's crust in the free state, some are found in the form of their compounds. The metals at the bottom of the activity series are the least reactive. Mentau, cognac. Welcome to Online Biology Tutorials Live. Dear, this is your question, ferrous and non-ferrous metals. So ferrous metals, they basically, as the name is clear, ferrous means iron. So they contains iron. That is why they are magnetic. And non-ferrous metals, they do not contain iron. That is why they are non-magnetic. There are other differences as well. Once I'll start the live of this chapter, you can join and you can ask more differences between them. So this is the basic difference between them. Please come to the next page. I hope this is visible to everybody. State, for example, gold, silver, platinum, and copper are found in the free state. Copper and silver are also found in the combined state as their sulfide or oxide ores. The metals at the top of the activity series, K, Na, calcium, magnesium, aluminium, are so reactive that they are never found in nature as free elements. The metals in the middle of the activity series, like zinc, iron, lead, etc., are moderately reactive. They are found in the earth crust mainly as oxides, sulfides, carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the earth. Thus, on the basis of reactivity, we can group the metals into the following three categories: metals of low reactivity, metals of medium reactivity, and metals of high reactivity. Different techniques are to be used for obtaining the metals falling in each category. Several steps are involved in the extraction of pure metal from ores. A summary of these steps is given in figure 3.10. Each step is explained in detail in the following sections. So a table has been given to you. You should go ahead with this. And in figure 3.19, this one activity series and related metallurgy. So these are separated by electrolysis. These are showing reduction using the carbon, and they are found in the native state, means they're talking about silver and gold. Silver is Ag and Au is gold. So let's talk about this table. Ore, concentration of ore. So after that, you can get metal of high reactivity, metal of medium reactivity, and of low reactivity. Metal of high reactivity can be separated by electrolysis of molten ore, and then we can get a pure metal. Metal of medium reactivity can be separated as carbonate ores or sulfide ores. Carbonate ores are treated with calcination, and sulfide ores, they undergo roasting. So once the oxide of metal is formed, then the reduction is done, and then the purification is done. The low reactivity ones, they are generally found as sulfide ores, so they can be undergoing roasting. Then the metal is collected and then the refining is done. 3.4.2 Enrichment of ores. Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. The processes used for removing the processes used for removing the gangue from the ore are based on the differences between the physical or chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. 3.4.3 Extracting metals low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar HGS is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide HgO. Mercuric oxide is then reduced to mercury on further heating. So 2HGS in solid form will react with oxygen, three molecules in the gaseous form. When heated, it will give 2HgO in the solid form plus 2SO2 in the gaseous form. Again, 2HgO in the solid form, when it is heated, it will give mercury plus oxygen. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. So 2Cu2S plus 3O2 in the gaseous form when heated will give you 2Cu2O solid form plus 2SO2 gas. 2CuO plus Cu2S when heated will give you copper in the free form along with sulfur dioxide gas. 3.4.4 Extracting metals in the middle of the activity series. The metals in the middle of the activity series, such as iron, zinc, lead, or copper, are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and the carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. So, the carbonate ores are changed into oxides by heating strongly in limited air. This process is called calcination. The chemical reaction that takes place during roasting and calcination of zinc oxides can be shown as follows. For roasting, zinc sulfide is heated with oxygen. When it is heated, it will give ZnO plus SO2. To balance, further numbers are added prior to these molecules. Calcination, zinc carbonate in the solid form when heated will give you ZnO solid form plus CO2 in the gaseous form. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. ZnO plus carbon in the solid form will give you Zn solid plus Cu in the gaseous form. You are already familiar with the process of oxidation and reduction explained in the first chapter. Obtaining metals from these compounds is also a reduction process. Beside using carbon coke to reduce metal oxide to metal, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminium, etc., are used as reducing agents. Next page. Because they can displace metals of low reactivity from their compounds. For example, when manganese dioxide is heated with aluminium powder, the following reaction takes place. MnO2 in the solid form, aluminium in the solid form. We will get manganese in the liquid form and aluminium oxide Al2O3 in the solid form along with heat. So this is exothermic reaction. Can you identify the substances that are getting oxidized and reduced? These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals produce in the molten state. In fact, the reaction of iron oxide Fe2O3 with aluminium is used to join railway tracks or cracked machine parts. This reaction is called a thermite reaction. Fe2O3 plus 2Al will give you 2Fe in the liquid form plus Al2O3 in the solid form along with heat. 3.4.5 Extracting metal towards the top of the activity series. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, that is the positively charged electrode. The reactions are at anode. Na plus will be getting an electron, so it will be forming a neutral atom, Na. At anode, 2Cl minus will be getting converted to Cl2 plus electrons. Similarly, aluminium is obtained by the electrolytic reduction of aluminium oxide. 3.4.6 Refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. In electrolytic refining, many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. The apparatus is set up as shown in figure 3.12. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. In text question, define the following terms: 1. Mineral, 2. Ore, 3. Gangue. 2. Name two metals which are found in nature in the free state. 3. Which chemical processes is used for obtaining a metal from its oxide? 3.5 Corrosion. You have learned the following about corrosion in chapter 1. Silver articles become black after some time when exposed to air. This is because it reacts with sulfur in the air to form a coating of silver sulfide. Copper reacts with moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. This green substance is basic copper carbonate. Iron, when exposed to moist air for a long time, acquires a coating of a brown, flaky substance called rust. Let us find out the conditions under which iron rust. Activity 3.14. Take three test tubes and place clean iron nails in each of them. Label these test tubes as A, B, and C. Pour some water in the test tube A and cork it. Pour boiled distilled water in test tube B and add about 1 ml of oil and cork it. The oil will float on water and prevent the air from dissolving in the water. Put some anhydrous calcium chloride in test tube C and cork it. Anhydrous calcium chloride will absorb the moisture, if any, from the air. Leave these test tubes for a few days and then observe. So the setup has been shown to you in figure 3.13. Need to go through all the diagrams carefully because any diagram may come in the board examination. You will observe that iron nails rust in test tube A, but they do not rust in test tube B and C. In the test tube A, the nails are exposed to both air and water. In the test tube B, the nails are exposed to only water, and the nails in test tube C are exposed to dry air. What does this tell us about the conditions under which iron articles rust? Next page. So we are doing the audio of chapter 3, metals and non-metals, class 10 NCERT. I hope this page is clear. Prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing, or by making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if zinc coating is broken. Can you reason this out? Alloying is a very good method of improving the properties of a metal, which can get the desired properties by this method. For example, iron is the most widely used metal, but it is never used in its pure state. This is because pure iron is very soft and stretches easily when hot, but it is mixed with a small amount of carbon, say about 0.05%. It becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust. Thus, if iron is mixed with some other substance, its properties change. In fact, the properties of any metal can be changed if it is mixed with some other substance. The substance added may be a metal or a non-metal. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. It is prepared by first melting the primary metal and then dissolving the other elements in it in definite proportions. It is then cooled to room temperature. Next one. Do you know? Pure gold, known as 24 karat gold, is very soft. It is therefore not suitable for making the jewelry. It is alloyed with either silver or copper to make it hard. Generally, in India, 22 karat gold is used for making ornaments. It means that 22 parts of pure gold is alloyed with 2 parts of either copper or silver. If one of the metal is mercury, then the alloy is known as amalgam. The electrical conductivity and the melting point of an alloy is less than that of the pure metals. For example, brass, an alloy of copper and zinc, Cu and Zn, and bronze, an alloy of copper and tin. The symbols for copper and tin are written here, Cu and Sn, are not good conductors of electricity, whereas copper is used for making electrical circuits. Solder, an alloy of lead and tin. Lead is Pb and tin is Sn, has a low melting point and is used for welding electrical wires together. The wonders of ancient Indian metallurgy. The iron pillar near the Qutub Minar in Delhi was built more than 1600 years ago by the iron workers of India. They had developed a process which prevented iron from rusting. For its quality of rust resistance, it has been examined by scientists from all the parts of the world. The iron pillar is 8-meter high and weighs 6 tons, means 6,000 kg. So the ink text questions. Question number one, metal oxides of zinc, magnesium, and copper wire were heated with the following metals. You need to write and fill the column. Metals that are given to you are zinc oxide, magnesium oxide, copper oxide. You need to write zinc, magnesium, and copper. In which cases will you find you need to fill where displacement reactions are going to happen? In which case, so I have already read this. Question number two, which metals do not corrode easily and what are alloys? Once you are done with the chapter, you should definitely go ahead with the summary, because in case you have left any point by mistake while reading out the chapter, you might grab it while going through the summary. So here is a summary for you. Elements can be classified as metals and non-metals. Metals are lustrous, malleable, ductile, and are good conductors of heat and electricity. They are solids at room temperature except mercury, which is a liquid. Metals can form positive ions by losing electrons to nonmetals. Metals combine with oxygen to form basic oxide. Aluminium oxide and zinc oxide show the properties of both basic as well as acidic oxides. That is why they are amphoreric oxides. Different metals have different reactivity with water and dilute acids. A list of common metals arranged in order of their reactivity series is known as activity series. Metals above hydrogen in the activity series can displace hydrogen from dilute acids. A more reactive metal displaces a less reactive metal from its salt solution. Metals occur in nature as free elements or in the form of their compounds. The extraction of metals from their ores and then refining them for use is called metallurgy. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. The surface of such metals, such as iron, is corroded when they are exposed to moist air for a long period of time. This phenomena is known as corrosion. Non-metals have properties opposite to that of the metals. They are neither malleable nor ductile. They are bad conductors of heat and electricity, except for graphite, which conducts electricity. Nonmetals form negatively charged ions by gaining electrons when reacting with metals. Nonmetals form oxides, which are either acidic or neutral. Nonmetals do not displace hydrogen from dilute acids, they react with hydrogen to form hydrides. So, with this, I am done with the live reading of Chapter 3 Metals and Nonmetals, Class 10 NCERT, that is followed in the CBSE board. I hope you were clear with the pronunciation. Once you are done with understanding the complete chapter, you must go ahead with the audio because it gives you a sense haven't you left anything or have you left anything. So make sure you read line by line of NCRT and become better equipped for the board examination. Consider subscribing. I will be starting with a live explanation shortly. Thank you to all the ones who have commented. Would be requesting you to share with your friends so that everybody can hear the audio whenever they will be comfortable. Thank you.